So hello, welcome to testing Vue components with Cypress. We're going to dive right in. First of all, I'm skipping the usual bio. This is more about how I feel right now. On the left, you see my profile picture that's everywhere. This guy looks pretty relaxed and calm. He's having like a chilled out day. On the inside though, when I talk about component testing, I feel like Anderson from Sherlock. I have all these papers and theories and connected dots and ideas. We're not going to get to all of those, but we are going to see some stuff in this talk that's just going to have to be ignored. We can follow up later. We'll see some examples of components that are doing stuff that makes no sense. That's okay. We're talking about testing them. So to start with, I have 7 failing component tests, which is the problem we're going to try to solve in this talk. And I want to start by working through fixing a couple of these components that are failing. And then we'll come back and we'll get into some background and context about what Cypress is, if you're not familiar, and how this works. In front of us, we have Cypress open. This may look different if you have not used Cypress in a couple of years or you're still on an old version. Things have changed since Cypress 10, and we're now on Cypress 12. We can see here there's like 7 failing tests. This is based on information recorded from like a CI run, and we can get into some of these tests and see what's going on. So my first component here is a paragraph component that's really simple. It's just going to render some text. And we can use Cypress to get into this test directly. We can see that it's failing. On the left-hand side is the reason for the failure. On the right-hand side is the paragraph component mounted in the browser. When I click through here, I can open this paragraph component test and see what's going on. So at a high level, what's happening is just that we import the component. We have a test that has a simple renders test, and we have a couple of assertions. So we mount the component and we expect a paragraph tag with this content. The test is failing because it can't find that paragraph tag. But I can see the tag here. I can see this content, so let's figure out what's going on. We can open up DevTools. Because we're in the browser, we can come through, and it's a div. I would like to apologize to Homer Gaines for using a div instead of a paragraph tag. Let's fix that now. We can click through, we can fix our components. We'll save the component, and Cypress has already rerun the test based on us modifying the component. So we can come back in and we can see it's passing now, and that's because we have a real div in the DOM. We have another way that we can access these tests. We can come through and look at like the next component spec here. This is also failing. This is a counter component. So now we're going to think about what's going wrong here. First of all, is our component working? This is live in the browser. We can click stuff. There's a plus. We click it. We do the counter. Everybody's favorite example is working great. So why do we have a failing test? It's a testing library selector this time. So this is a Cypress testing library that's the same as other testing libraries that you can use to use accessible selectors. So we're not finding a button that we expect here. We'll come back through, we'll look at this one. And this failure is because, oh no, we have a div again. We have a clickable div which works in the browser, but it's not accessible. You don't get any of the keyboard behavior for free like you do with a real button. So in this case, we'll fix the button. And now our test is rerun and it's passing again. So based on this cycle of modifying the component files and then going back and looking at the test and working on the test, we're able to have this really nice development workflow. And you'll notice what I'm not doing is fixing any of these by changing the test itself. The test is really the spec for the expected behavior of this component. So if I have a failing test, usually it's because I messed up the component and didn't make it work to the spec that's in the test. So when we're looking at what this test does, we want a paragraph with 0. We want to find this button test, and we'll click and we'll click. 0 should go away, 2 should be what's there. And that's what we see as we go through this test here. So that's like an introduction to Cypress if you've never used it before. And I know there's people here who have used Cypress a bunch, there's people here who have used Vue a bunch, and there's people who are brand new. Let's just take a little moment to talk about what Cypress is. First up, what we just saw is the Cypress app. It's a free and open source tool. You can test anything that runs in a browser. People use it for end-to-end components and API testing. Those are all pretty common uses of Cypress now. If you felt like it, you could run unit tests in here, but there's no need to because unit tests don't typically use a browser. The Cypress Cloud is the other part of our company. So this is a product that you can purchase or you can use it for free if you have an open source project. This has the historical test data. That's those red X's and that's 7 on the debug page based on cloud runs that are recorded. And it has a few other features as well, like orchestrating the order in which your tests will run and spreading them out efficiently and stuff like that. If you have used component tests before, this type of thing might be familiar to you. And if you've written component tests in Vue before, you might be used to doing stuff like vm.nextTick or await flush promises is another classic. And I don't think that we have to do those things in Cypress because we're in the browser. But what you may think of when you think of component tests is debugging HTML logged out to the console in your terminal and trying to work from there to picture what the component looked like when it rendered. But it didn't actually render. There was no browser involved. It didn't go through a CSS rendering engine belonging to any browser. So you have to kind of imagine how this would have worked. In Cypress, like we just saw, we have the DOM, the real DOM that's happening in the browser. We can inspect and debug with that. And we have the live kind of command log on the left, reporting our test as it happens. I sometimes forget to do shoutouts, so I put in this slide, Hi Jess. Because one of the nice things about this conference is we have those brand new people just getting to know the tools. And then we have people in the room who built the tools that we're talking about. So Jess led the team that developed component testing in Cypress, and she hired me to work there, and that's why I'm here talking about this today. So thank you, Jess. So like Eric said, right? Eric talked about end-to-end testing just now with Cypress, and that's certainly the most common thing that Cypress is known for. You run your application in a development server, you visit the home page or whatever page you want in your Cypress test, and then you can perform all these interactions. And it's really simulating the experience of a user doing something like buying products from you or, other important activities on your website. The key thing is, your whole website is deployed and running somewhere, even locally, and you're using the URL to start your test. No matter what other things you have going on, you go to a URL and you kick it off from there. In component testing, the beginning of the test is a mount command. We're importing a component, and we're going to mount it into this otherwise empty page. You can control that page. You can set extra things in there. You can provide like CSS that your component needs. But there is no URL. You aren't on a page of your application. And we're going to use props and slots and other things that a component can use to set up the initial state. Everything else is the same. If you're already familiar with end-to-end testing in Cypress, you can do all of the same things you're used to, including network stubbing, all the commands. The only things you can't do are really related to like switching domains. But that's fine because you're not on a website. You're just loading a component. The main difference to me between like the philosophy of testing components this way compared to Vue test utils, which is still used under the hood in Cypress, by the way. Vue test utils is where that mount command comes from. So you have like an escape hatch to do things if you need to. But it's much more natural to just test through what the user would do in the browser. So we click things, we see what happened on the page, did the counter update correctly. We're not going to look for like a computed value by name and find out internally in the component, is that state correct? I've often seen jest-based tests that look at those internal methods and values in a component. And I think some of the reason that we do that is because managing time in JS DOM is difficult and we have to, again, await specific framework events and stuff like that. In Cypress, it's much more natural to just text the implementation through the effect on the user. Okay, I don't know about you, but we're going to have to fix all 7 of these for me to be satisfied with how this talk is going. and to just deal with what's going on in front of us. I use these components for teaching, so a lot of them have like kind of a pointlessness to them. Like this is the same, it's just got styles on it as the last counter, but this is failing. And it's failing because we can't click it. And even if I try, I'm clicking right now on the button, nothing happens. We look at the error in Cypress. That's the button we want to click. It's being covered by an element with a class button interferer. That seems suspicious. If I try to inspect this, yeah, there's a div with button interferer. And it's got some styles. So let's go find out what's happening here. I wish everything was this easy. Okay, so that's fine. Let's say we want to leave it there, but let's remove all the styles. And so because we have this browser running, we can catch that CSS bug, and we can fix it, and we can know that we've fixed it. So I think that's good. I think that is a much easier way to figure out what's going on than looking at the output in the terminal. All right, now we're doing slots and props. Now we have a 15 that's supposed to be 16. I want to preface this by saying what we're about to do is a little bit silly. You would normally be checking font sizes and visual appearance with like a true visual regression test just based on how it looks. But let's take a look at it. So in this case, we're using JSX in the mount function, which you can do. We can put a slot in here just like we would, and we can pass in a value in the prop. This first one here is passing. This is a sci.contains again with a selector for a paragraph with the class of large. I do not recommend doing this because this has the right class, but it's still not doing the right behavior. This text is normal size. So we have this other test. Again, it's silly, ignore it. We're grabbing the font size and we're just saying it should be greater than 16. This represents any way to test something like this. It's not greater than 16 because we have a style that's not working correctly. So we come back to our large class and somebody decided to set it in VW units, which is not ideal for font size. So we're going to switch this to rems. And now all of our tests are passing. We can look into this one and we can see, okay, that's big. That was pretty big over here. It's 48 is above 16. So the Cypress test is passing. We're happy. It's a little bit funky, but this is a way to use the CSS effect to determine what's the computed style and make some assertions about that. That might be really important to you in your application, and you might want this faster feedback than waiting for visual regression to run somewhere else. So you may actually do something like this if your app is really visual and this kind of thing is important to you. Now we have a counter that uses that other paragraph component. And this is having some misbehaving as well. Let's see what's happening here. Now we can't find a label with the text of increased count. So we're going to inspect this component test. We can see this is where it's failing, right? We can't get this label here. And that's because we removed the label and it's just a plus. So we're going to put this label back in here. And I really like this kind of test instead of, or as well as like data test ID or data sci attributes, if you're used to using those, because I really want the test as much as possible to hold the application the same way that a user would. So put this label back in. Now we're passing. We're able to find this button by that. So we didn't need a special attribute to find this button. We could put in something that's actually meaningful to users. I want this test to fail if we remove the ARIA label, because that's what's announced to screen readers, and it's used in various other kind of accessibility technologies as well. So as much as possible, we can hold the application this way in the component tests. Okay, we have another failure. This goes up to 11. That'll be relevant in a minute. So here we have a test that's like, okay, we're increasing it. Right? We have a spy here on an event. So when I use this component, I'm teaching about view events that can be emitted and how we can spy on them in Cypress and test that the event is emitted. And I know that that's not user-facing in the same way as like what's happening in the DOM, but it is important because those events and their names are part of the surface area of the component. They're part of the API of the component. It's important that we keep those stable, or at least we know that they've changed. So a test like this that explicitly checks something of an event is still worth having. Okay, so let's go through, let's find where this is failing. In fact, let's see what didn't happen first. Oh, we expected this exception to have been called. So this is a spy on when there's an error thrown by a Vue component. I think this is actually a legitimate thing to do if you want parents to be able to handle the error and not decide in this component to squash it. We have a component that's supposed to throw an error when we go up to 11. And the component test is using Cypress to expect that error. So we have like it's a little bit of a hoop to jump through, but we can make a stub and we call the stub when we find the error and then we ignore the error. And that might seem like a little bit of a rigmarole, but when we just get through it here, cool, we're passing. We got the error that we wanted. We can see it in the console. Excellent. So that error being tested in Cypress is like slightly more advanced than most cases that you would use, but I still think it's interesting. Vue components can happily throw errors and we can test for them. And then we have a parent component. This is the final thing that we're going to test. That was confetti. If you weren't sure, that was emoji confetti from the library Emoji Explosion, which is by Josh Goldberg. It's fantastic. I'm using it all the time in demos. I love it. We talk about time travel debugging in Cypress, and one way to think of that is you look on the left and you can see the commands, what was happening as you go through, and then like, okay, cool. I think that like that's much more compelling as time travel debugging. So what happens here is we never see the loading state. It says contains loading, and we didn't find the text loaded. So we might have a couple of steps to fix in this test here. In fact, not in the test, in the components. Test should be okay. Yeah, okay, somebody commented out loading and put emoji explosion. Somebody got ahead of themselves here. That's okay, let's save that. I probably should remove this emoji explosion function call as well. So now we have like the structure we looked at earlier. This one emits an event, so we have a handler for this event. Handle counted to 5. This is a Star Wars API request. Don't have time to talk about Star Wars API, but basically we're going to go and get a Star Wars character when this counts to 5. Now we're passing. There's a error state with Nigel Tufnell here that happens at the end, and we can still do great because we're still in the browser. We can still play with the component. But now this one here is also passing. We were able to intercept this call and see that we got Luke Skywalker here. It's a whole bunch of states that like we didn't see because it happened so fast. But this is the path of what's happened. This final one is using a Cypress intercepts to say that person 1 in the Star Wars API should be Chewbacca. I think that's, in some circles, a controversial take, but that's what we can do with the intercept. If that was the case, this is what would happen. And so those are our 7 tests. Those are passing. And if we were to switch branches to where they're all passing, yeah, let's just do it. Come back here, and we can see we have all of our green check marks. So on that branch, we recorded the tests. They're all green. Okay. There's a tiny other thing I want to talk about. Whereas we're testing these components as a user and the side.mount is kind of Vue specific, all the other code, like I said, can be reused. So within this application that we're in, there's a bunch of component tests. Let's take a look at like this button test. Really simple, happy button. Got all this other stuff here. The important thing is this is like I said with Anderson and the structure behind him and all the things connected. I'm not going to go into the weeds on this, but we can sort of see these component tests as little fragments of other front-end tests. So they have this arranged part where they mount, and then they just do front-end testing stuff. And this means if you really feel like it, you can test bigger and bigger components. This is testing an entire view. If we look at the code here, we're seeing a lot of stuff here. And if we look at the app test, this is testing the app component, and it's going on and on and on. And under the hood, this is just calling little validators that are front-end validators. Finally, I'll switch to end-to-end testing because I think it's not important that you would ever follow a pattern like this, but we can see the home end-to-end test is visiting a URL. It's doing a bunch of stuff, and it has those same like 300-ish lines. This is far too intense, but it's reusing those same fragments. So when we look at the code for this homepage test, it's using a custom command called validate and passing in a couple of states of the app that we want to check. You can imagine how funky the code under this is. I don't think this is a full pattern that we should use, but I think it's interesting because if you have a complicated component like a date picker or a checkout form or like a credit card application, and you're developing it and you test it for component testing, you can reuse all the user-facing stuff when you get to integration testing and end-to-end testing. And you can pass it the expected values for like a real end-to-end test instead of what you're stubbing out in your components. And for really critical, complicated stuff like that, you used to have component tests in one world and end-to-end tests that were totally different, and you couldn't share custom commands between them. But in Cypress you can, and I think that's a really valuable feature of using component tests and end-to-end tests stacked in the same framework. So let's start summing up. Here's why component tests are neat. It's a single place to talk about all the components' behavior. We didn't get into that in all the tests, but basically the test file is the spec for the component. Everything you do in there, especially locating elements, is part of the spec if it can make things fail. So if you're locating by CSS classes or other kind of ways of locating elements that don't match what users need, that's part of the spec of your components, and that seems a little weird to me. So accessibility first is the way I recommend testing. I like all of the pre-coverage of the API of the component, and I say this because I write component tests in order to see what's going on for development. I want to see the component in every state that's like in Figma that it's supposed to be in. So I'm mounting it with all the different props it can have. And as we do that, we're able to see exactly what's happening with each of those states, and then I can make assertions later. But like you were going to have to do that work anyway, somewhere, to get it to be in a state that you want. So I feel like a lot of the component test is just a leftover artifact from trying to see it and develop it. We get to write better isolated components. It's slightly easier to specify a component if it does something that's easy to understand. So if it's difficult to write a test and it's doing a million different things, that also might be a sign that the component is like conceptually a little bit too heavy and overburdened. I really like the workflow we just looked at, where you sort of click through a test in Cypress and then you click into VS Code and then you can kind of come back and see what's happening in Cypress again. Live reloading when you write the test, live reloading when you write the component. All of that seems really friendly to me and makes it feel really fluid to bounce back and forth. And finally, like I said about accessibility testing, if the component tests are written by developers writing components who understand the accessibility of their components, maybe then it's okay in the end-to-end test to not do such a deep check of accessibility every time. So I see component tests as really vertical. We want to know what is the exact correct DOM we expect. That's an important part of our components. But the end-to-end tests can be way more horizontal. They can just go through user journeys. They don't have to hold the application the same way. If you want to use data test attributes to make them more stable, it's kind of okay if you have asserted the accessibility things earlier in your testing. It's really quick to get started. You can install it, you can try it. If you have a Vue project, it will be detected. You just click some stuff a few times and it should be up and running, and you can start to write a component test for any existing component. I put the URL for the slides up here because of these links at the back especially. So if you are looking for other ways to learn about component testing in Cypress, here's a few reference points for you. You can also just get in our Discord, tag me personally. I will reply to you, or put it in the component testing channel. I have some organizations I'm involved with, but we don't have too much time to talk about those. So let's wrap it up here, and thank you very much.